A linear function is a function where rate of change is constant. Linear function consists of an independent variable, a dependent variable, and both raised to the power 1 only. Graph of a linear function is always a straight line. A linear function in two variables can also be written as a linear equation in two variables. So an example written in the function form would be f of x equals negative 2x plus 3. Or g of x, it could be g of x, h of x, any two variables related to each other. Height could be a function of the distance traveled or the time. So another example can be f of x equals negative 3.5 x minus 1. It could be the number of hours you work and your paycheck. A relationship between them could also be represented using a linear function. There's many applications of linear functions in everyday life. For example, age problems, speed, time and distance problems, geometry problems, percentage and money problems, pressure and force problems, and salary problems, and many more. A linear equation in two variables can be expressed in a few different forms. We can express it in the slope-intercept form, where y is equal to mx plus b is the slope-intercept form. M is the slope of the line, b is the y-intercept. We can also express it in the standard form, where ax plus by equals c. A, b, and c are integers here. Point slope form is y minus y1 equals m, x minus x1, where m is the slope and x1, y1 is a point on the line. Methods to graph linear equation in two variables. We can graph by making a table. Pick any x values. Two x values should be good enough to give us indication where the graph is headed, but it's good to pick three to make sure we found the corresponding y values correctly. Pick any two x values and find the corresponding y values, plot the points and connect. That would be graph by making the table. We could also use x and y intercepts to graph a linear equation in two variables. To find x-intercept, we will plug y as 0 and solve for x. X-intercept is a point on the graph where graph touches the x-axis. Y-intercept is a point where graph touches the y-axis. And to find y-intercept, we will plug x equals 0 and solve for y. We'll find both x and y intercepts, plot them, connect the dots, and that'll be graph for that line. If both x and y intercepts are 0, then we will have to use another method. This method would not work. Next, we could also graph linear equation in two variables using slope and y-intercept. So we'll start by plotting the y-intercept and then look at rise over run from there. If it's positive, we'll rise up and go to the right. If it's negative, we'll go down, go to the right. We can also go to the left. Sometimes we'll see an example. So let's see examples of graphing linear equations in two variables. The first one, I'm going to be using slope-intercept form to make this graph. So y equals mx plus b. B here is the y-intercept. So I'm going to start by plotting positive 5 on the y-axis because that's the y-intercept. From here, my rise is negative 2 over 3. Rise over run is the slope, which is negative 2 over 3. The negative in the middle of the fraction can be considered with the numerator, with the denominator, either one, not with both at the same time. So rise is negative 2. That means I'm going to go down 2 and 3 towards the right. And my equation is going to, graph of the equation is going to look something like this. And we can clearly see it has a negative slope. As x's are becoming very, very large, y's are becoming smaller. So negative slope for this equation. Let's graph number 2, y equals 4x minus 5. So for this one, we're going to start with, again, mx plus b. We're going to use slope-intercept form to graph. Start with negative 5 on the y-axis. And in this case, m is 4. We can think of it like 4 over 1. So start with negative 5 on the y-axis. Go up 4 over 1. Connect the dots. And that's how the graph is going to look like for this equation. Another one, y equals x over 2. We can go ahead and use a slope-intercept form. We can go ahead and make a table, either one. So I'm going to do both here just to show both the methods. So if we were to use a slope-intercept form, we can write it as y equals 1/2 x plus 0. Just rewriting the equation tells me that my y-intercept is 0, rise is 1, run is 2. and that's how my equation will look like. I could go ahead and make a table here as well, which we can do for any of the linear equations or any of the equations. We can always make a table and make the graph. Sometimes it's not the best way to make the graph, it's not the fastest way, but it always works. So I could pick some values of x. Let's go ahead and pick x as -1. X, actually, because I have 2 in the denominator, I'm going to pick multiples of that denominator. I'm going to pick x as -2, 0, and +2. So if x is +2, y would be equal to 1. If x is 0, y would be 0. If x is -2, y would be -1. So here's my point right here. And this is how my graph should look like. Ignore the second. So we had go. Okay. Let's double check. I don't think my points are correct, but we're going to take another look. So we started at 0, go up 1 over 2. That's how we got the graph using slope and y-intercept form. When x is 0, y is 0, so that point is correct, 0, 0. When x is 2, y is equal to 1, that point is correct as well. When x is -2, y is equal to -1. All right, so there is our graph by making table as well as by using the slope and y-intercept. For number 4, because my equation is in the standard form, I can write it in the slope-intercept form and then use slope and y-intercept to graph, or I'm going to go ahead and use the intercepts. To find x-intercept, I'm going to make the y 0, so 2x equals 6. X-intercept comes out to be 3, or we can say 3, 0 in coordinate form. And to find the y-intercept, we're going to make the x 0. So that's 0 plus 3y equals 6. Y comes out to be 2. So y-intercept is 2. An equation of line, graph of this line looks like this. Quickly, before we move on, I want to discuss the slope of each of these lines. This line would have a negative slope because it's going down, negative slope. The next line has a positive slope because it's going up on the right-hand side. The next one is also going up on the right-hand side, so positive slope. And the next one is going down as you're going to the right, so negative slope. See a couple more examples of graphing. Now, both of these equations are linear equations in 2 variables. They're just not written in the nice shape and form. So first step would be to put them in the nice shape and form. We can get them in the slope-intercept form or standard form, however, and then proceed for graphing. I'm going to try to bring variables on one side, isolate the y on one side here. So I would be left with 2y equals x minus 2x is negative x. And the 2 and 2 on both sides will cancel. So y is equal to -1/2 x is what we're left with. Again, it's easier to use a slope-intercept form here. Start with 0 because we can always add a 0 here. And y-intercept, if we compare to mx plus b, the b will be 0. Now rises -1, go down 1 and over 2, and that's how the graph of this equation will look like. Again, we have a negative slope here. Number 6 is similar. I need to isolate the y first, so 2y plus 4x equals 6x plus y. Now bring y's on one side. Y comes out to be y is equal to 2x, and we can always put a plus 0. Looks like the rise is going to be 2 and the run will be 1 because 2 can be also written as 2 over 1. Start with 0, go up 2 over 1, and that's the graph of this equation. Again, this one has a positive slope. Now graphing the equations, vertical and horizontal equations. Now, each of the ones we saw is a graph of the function because they will pass the vertical line test. But in the bottom 2 examples, we will notice that one of these will not pass the vertical line test. Let's go ahead and graph x equals 3. If I want to graph x equals 3 by making a table, so x can be 3, y can be anything, 0, 1, 2, 5, 10, whatever. It doesn't care for what y becomes, but x is always going to equal 3. So that is going to be a line that is passing through Up and down line, vertical line passing through x equals 3. And this line, let's think about the slope of this line and also think about if it's a function or not. If we do the vertical line test, this is going to fail the vertical line test because my vertical line is going to touch this graph at many points, infinite many points. So this is not a function, and the slope in this case would be, think about rise over run. Does this line rise up and down? Yes, it has some rise. It's going up and down. Does this go left and right? Is there any run? No, there's zero run. So any number divided by zero is undefined. So slope for a vertical line, x equal to some number, is going to be undefined. Let's graph the next one, y equals -2. Y equals -2 means it doesn't care for what x becomes. Y is always going to be -2. So it's going to be a horizontal line passing through y equals -2. And for this line, we can see it is going to be a function because it will pass the vertical line test. We can draw any vertical line through this graph, and that would not be touching the graph at more than one point. So it passes the vertical line test, and it's a horizontal line. Think about the slope of this line, rise over run. Does this line have any rise? No. Does it go left and right? Yes. There is some run, there is no rise. 0 divided by any number is 0. So slope in this case is going to be 0 for this horizontal line. All right, next we're going to change this given equation into slope-intercept form, then standard form, then find the slope of the line and give an ordered pair on this line. So to change it, this is given in the point slope form because it's y minus y1 equals m x minus x1. So this equation is given in the point slope form. We want to change it to slope intercept form. In the point slope form, m is the slope, so we can clearly see the slope is going to be 3 here, and a point -1, 2 is on the line. Point -1, 2 is on the line. So let's go ahead and change it to slope intercept form. To get the slope intercept form, we need to isolate the y on one side. So we are left with 3x plus 3 plus 2. Y is equal to 3x plus 5. Okay, and that's our equation of line. Y is equal to 3x plus 5 is the slope intercept form of this line. Now if we were to write it in the standard form, we bring x and y together on one side. -3x plus y equals 5 would be standard form. We could write it as y minus 3x equals 5 as well. Slope of this line is 3. It's not -3 because this is where we will be looking for the slope, or here this is not giving us a slope because we don't have y by itself yet. Next, we're looking for an ordered pair on this graph. So we can give any point. We just earlier said -1, 2 is 1 point on this line. We can find another point. I can just choose x to be 1 and find the corresponding y value. So if I choose x to be 1, y would be equal to 8. We can find any number of points. There's infinite points on this line. We can choose x to be anything and find the corresponding y value by either plugging in here or by plugging in here, and we would be able to find the coordinate pair. Give the intercepts, the x-intercept here. To find the x-intercept, so my equation is y is equal to 3x plus 5. To find x-intercept, we plug y equal to 0. So we're going to go 0 equals 3x plus 5, and that would, to isolate x, turns out to be -5 over 3 equals x. So x-intercept would be -5 over 3 comma 0. That's the coordinate pair. That's the point where graph is going to touch the x-axis. And now to find the y-intercept, we can plug x as 0. So 3 times 0 plus 5, y equals 5. So 0 comma 5 is the y-intercept in the coordinate pair form. Next, we have few equations, and we are looking at the slope, x-intercept, and y-intercept of each of these. For y equals -3, we said the graph is going to look like y equals -3 would be a line like this, and x equals 5 would be a line like this, x and y, x and y, x and y. Y equals x is y equals 1x plus 0. So it's a special line with the slope. Parent function, the basic linear function y equals x. Slope is 45 degrees angle it makes, and the slope is 1 here. So this makes an angle of 45 degrees with the x-axis. Right, so slope for the first line is going to be, we earlier discussed that in this case the slope is 0. Okay, let's go ahead and do it again. Slope in this case is 0, and slope for next line is undefined. Slope is 1 for the next line. For y is equal to -3, x-intercept is none. This graph is not going to touch x-axis at all. It is going to touch the y-axis at -3. The next graph, x-intercept is 5, 0, and it does not have any y-intercept. It's never going to touch the y-axis. For next one, the x-intercept is 0, 0. Y-intercept is also 0, 0. It only touches the graph, only touches the x and y axis at origin only. That was all for intro to linear functions. In the next video, we'll talk about writing equation of a linear function.